Different ways to graph. Occasionally we're going to say, okay, do this one by hand, so you know how to graph it by hand, but a lot of them we'll use on Desmos as well, and you'll appreciate that more once we do it by hand, what that entails. So the first question is some reminders of when we made this trail mix. You know, is it in the same ratio? Not concerned about that. We're going to hop right into number 2 with the graphing portion, because it is a problem we've already discussed, and it even mentions that. It says write an equation to represent what it's talking about. So how do I show how much raisins are going to cost me in that first example? Based on the information that you see. Go ahead, Caleb.
Put it like 4 for 4R.
Yeah, it does say to use X for raisins, but R would have been fine otherwise. So 4X. And walnuts?
Plus Y
Equals?
equals $15.
Yeah, so there's 3 different ways here to graph it. Okay, once again, we could do the method like you did on the warm-up. I could find the x-intercept and the y-intercept. So plug in 0 for both of them. So if x is 0, 8 times what is 15? So what's 15 divided by 8? 1.875. And if I plug in 0 for y, 4 times what is 15? So 15 divided by 4. And then I could just quickly sketch that. 3.750. Gonna be about right here. 0 and 1.875, and you could connect the dots and there'd be your line. And that's a sketch, of course. I could solve it for y by subtracting 4x and then divide by 8. That is a second way I could do it. So again, y-intercept is 1.875, down 1, to the right 2, down 1, to the right 2, and then connect the dots. So that is a second way you can graph it. Third way, I'm going to show you how to do that on Desmos. Caleb's going to let me borrow that again. So just type it in right as you see it. Somebody can read it for me. I just covered it up. Was it 4x? 8y equals 15. Okay, so there's the same graph. Again, 3 different ways to do it. We did it by hand, found it. We could graph this, found it using Desmos. If it says use technology, that is fine. Okay, let's complete the table. If raisins is 0, what do I plug in for number of walnuts? Okay, how'd you get that?
It's your Y.
It's your y-intercept. We already figured that one out, right? It's a point right there as well. Gives it to me. How about 0.25? So you could plug it in. I think I can just tell this thing to. Where does x equals 0.25? So I just typed in x equals 0.25. And there it is right there. 1.75. Next one, it gives me the y. Gives me the pounds of walnuts. So instead of x here, I'm going to write y equals 1.375. And I, again, looking just where they cross. So I click on that. And what is X? What is my pound of raisins? 1. Same thing with 1.25. Where do they cross? 1.25. It gives me raisins again, so that's X equals 1.75.
Wait, you just put the equation on top and then just write that below?
Yep. So that would be 1. 3 pounds of raisins. Get 0.0375. Questions on that? Again, nice to use technology, right? I don't have to plug it all in myself. Just see where they cross. Obviously, your equations need to be inputted correctly for that to work. Okay, take a look at the next one. Let's do this one by hand. I put a little note there. We're going to do this one by hand. Write an equation, represent 2 pounds of raisins and walnuts. Well, they have to equal 2. So I'm just worried about the weight now, nothing with the cost. Graph it. Well, if X is 0, what's Y? 2. If Y is 0, what is X? 2. Okay, so there's your graph. Pretty simple. It's a sketch. You could do graph paper and make it look prettier. So we're just talking about pounds now, got to equal 2. About 2 pounds. So if I buy 0 raisins, how many walnuts did I buy? 2. Yeah, you just told me that down here. How about if I buy a 1/4 pound of raisins, how many almonds did I buy? Again, it's just got to equal 2. How about next to the 1.375? Next to the 1.25? Last one? Because you can't buy -1 pounds of something.
It could go on the graph.
I guess you could go buy 3 pounds of raisins and give them a pound of walnuts. So it's not possible. All right, so I'm going to graph both of those equations. The first one I already have in there. We're going to graph the second one. Because question C says, when can we spend $15 and buy exactly 2 pounds?
Wait, why do you still have the first equation under it? I thought we were doing that.
Both stipulations for question 3. So they want you to spend $15 and buy exactly 2 pounds. So the top one had to do with spending $15. This one's spending or buying 2 pounds. Go ahead.
So it's where they cross.
Yeah, it happens one time. And it's going to be right there. So if you plug that in, you'll get exactly $15. And you will get exactly 2 pounds. And you'll notice it was on both of my charts as well, if you look at that. Top of page 235 and the bottom. So he bought 0.25 pounds of raisins. and 1.75 pounds of walnuts. So it will happen one time. Obviously, those lines will never cross again. One intersection point, that is the answer to both equations. Happens one time. All right, question number 3. This is kind of going to be a preview of the one that we will talk about tomorrow, a method that we will use tomorrow. So we're going to do one by hand and then use Desmos for the other two. So if you want to write a little solve by hand for number 1 there, so you have an example if I were to ask you that. Dining hall has a total of 25 tables. Long table seat 8, round 6. All 190 tables will be, seats will be used. So the first thing, 2 equations. First one, I have a total of 25 tables. Long plus round equals 25. I think you can come up with a second equation.
8x plus 6y.
There you go. So those are my 2 equations. Now this is jumping the gun a little bit, but I'm going to prove, we're going to go through a substitution method. We're going to solve for the first one. Do you want to solve it for x or y? Your choice. You want to solve it for y. Okay, so I would have to subtract x. Everybody agree with that so far? Now, because I know what y is, I'm going to substitute that in for that y right there. So it's going to be 8x plus 6 times y, which you just told me now is that, equals 190. Can you take 6 times negative x for me?
Negative 6.
6 times 25 for me? 6 quarters.
130.
How much is 6 quarters worth? 150 is correct. I'm going to combine the x's.
Yeah. Negative, or,
2x,
yes.
8 minus 6. Now what do you think?
Get rid of 150.
Get rid of 150 by subtracting it, so 2x equals 40.
20.
No, I heard you say x is 20. So there are 20 long tables, that's what x was. How many round? 5.
Wait, are we trying to find, like, how many, like, what are we trying to find? When they, like, intersect?
Yes.
But, like, what does that mean?
That means you will have a total of 25 tables and they will seat 190 people. And if you were to graph it, just like you did in the last one with the walnuts and raisins, there'd be one spot where they meet. Okay, so again, that will come more tomorrow, but I wanted to give you a preview. That's called the substitution method. You solve it for one and you substitute it into the other. Yeah, there's going to be a couple of different methods we will talk about. The first being substitution. I guess not tomorrow with the quiz, Thursday. All right, question number 2. We're going to do the same thing. This one we're going to plug into Desmos, but you have to get the equations correct. Family bought a total of 16 adult and children's tickets. So again, here it says to use A and C though. So what do you think my first equation is?
A plus C equals 16.
There you go. And now it starts to give you the prices. Adult tickets are $10.50, so 10.50A.
Plus 7.50C equals 141.
There you go. So those are your 2 equations. So now, Georgia, you asked what we're going to do. We're going to find out when we have 16 tickets and it costs $141. So we're gonna plug those into Desmos. I don't believe it's gonna like A and C, so I'm just gonna use X and Y.
X or A.
Yeah, so X plus Y equals 16. And what was it, 1050X plus 750
equals
Y.
141.
Okay, again, you should have a spot where they meet there. If you click on it, there should a little gray dot should show up. And if you click on it, that means 7 and 9 is where they will meet. So that means 7 adult tickets, 9 children. They add up to 16. And if you were to figure it out, it would cost exactly $141. Okay, I'm going to give you a minute. Why don't you see if you can just write the equation for 3? Just see if you can write the equation for 3. How you're doing large and small posters.
It gives a specific number of prices.
It does.
So,
Just try it.
yeah.
If you want to check your equations with mine, you're welcome.
It doesn't.
Okay, 2 large, 3 small for 1680, 1 large and 4 small for 1415.
It doesn't matter if you have your price first, does it?
Nope. Once again, I would just graph them. Put them both on there, see where they meet. And that is where the large and small, how many you will buy, that will cost you exactly the same price. Yeah,
Let me go to the bathroom.
sure. All right, what do we get? 4.95 and what?
2.3.
So 4.95 is the cost of the large poster. Small poster costs $230. So again, just type them in, see where they meet. Last thing I want to mention, if you ever see a question like top of page 237, just number 1 I want to look at. If it ever says make up an equation that where they cross, so you want them to intersect at 4, 1, which would be right there. Easiest spot would be to draw a vertical line. Vertical line equation is always x equals, in this case it's x equals 4. And then if I want to meet there, I'm going to draw a horizontal line.
Y equals
and that would be y equals 1. So if you'd ever see one like that, just know that x equals is always vertical, y equals is always horizontal, if it's just one number.
And how do you make it?
That is the equation. If you were to graph that, that's exactly what it would look like. Try it if you want, Georgia, on Desmos. All right, homework. Question 1, pretty self-explanatory. That's what we did today. Question number 2, I do want to mention this one. Okay, this one's going to take a little bit of work on your end. It wants to know if it works. So if you look at number 1 here, I made a little chart, equation 1 and equation 2. So I'm going to plug in 3 for equation 1 here. So what's 6 times 3? Plus 4 times 4. So is 18 plus 16, 34. So I'm going to write, yes, it does work for equation 1. Now I'm going to plug that equation in for B, number 2 here. 3 times 5, 15. Minus 2 times 4 is 15 minus 8, 15. So it does not work for that one. So that's what I'm going to do for all those. Okay, that's what I'm going to do for all those. The rest are pretty self-explanatory. Just be careful for the word explain. Just make sure when you tell what you did. Okay, so that is it for today. Go ahead and get rolling on the rest of them.